Hi, this is Cliff from Redwood Tutoring. I want to talk with you about square roots. Well, let's start off with a definition. If I have a number, r, and if r squared gives me a, then I say that r is a square root of a. So for instance, since 5 squared equals 25, this means that 5 is a square root of 25. Now, as it turns out, 5 is not the only square root of 25. There's another one. Since -5 squared, which is -5 times -5, is also 25, this means that -5 is also a square root of 25. In fact, every positive number, not just 25, every positive number has 2 square roots, one of them being positive and the other negative. I want to set up a chart, and in my chart, on the left-hand side, I'm going to list a few numbers, and on the right-hand side, I'm going to list both of the square roots of those numbers. Before I actually write it down, see if you could come up with the numbers before I do. So here are the numbers, and then over here are the square roots of the number. So let's start off with 81. I asked myself, what squared gives me 81? Well, I know that 9 squared gives me 81, but also -9 times -9 gives me 81. See if you could get this next one. 49. Well, 7 and -7 do the trick. How about this one? 121. Well, as it turns out, 11 and -11 are the 2 square roots of 121. Now, every positive number has 2 square roots, one being positive and one being negative. Here's the way that we denote each of them. The way I pronounce this is the square root of 25, or for short I might just say root 25. And this is going to represent the positive, or it's often called the principal. Square root of 25. So the symbol for the positive or the principal square root is given by this expression. Now, if I want to write the negative square root, I just put a negative sign in front. So negative root 25 represents the negative square root of 25. So for this one, the square root of 25, that's the positive square root of 25, this is going to give me 5. But if I had a negative in front, this is asking for the negative square root of 25. This is going to be equal to -5. Now, I want to do a few more problems and see if you could get the answer before I actually write it down. Let's suppose that I want the square root of 64. Well, I ask myself, what squared gives me 64? Well, I know that 8 squared gives me 64. And I also know that this is asking me for the principal or the positive square root. On the other hand, if I wanted to give the answer to negative root 36, well, I know that 6 squared is 36, But here I'm interested in the negative square root. My answer is going to be negative 6. How about this one? Let's suppose that I have the square root of 1. Well, this is going to be asking for the principal square root of 1, that's 1. Here, if I want negative root 144, this is asking for the negative square root of 144, that is negative 12. Now, I want to show you guys a trick that I think you'll find very useful. Let's go back to the square root of 25 again. Well, I know that 25 is just 5 times 5, so this could be rewritten as root 5 times 5. And we also know that that's equal to 5. In fact, the same sort of process could be used if I have the square root of 9. Well, this is just going to be the square root of 3 times 3, and that's going to be equal to 3. In general, there's a fact that we're going to find very useful, and the fact goes like this. If I have any non-negative x, the square root of x times x equals x. If x is non-negative, that is, if x is greater than or equal to 0. So if you give me any x that's greater than or equal to 0, the square root of x times x is equal to x. The expression that I have for this is that for every pair underneath a square root, I take one representative outside of the square root. Every pair under the square root equals one outside of the square root. So let me go ahead and close this time with 3 problems where I make use of this fact. I'm going to erase the board to give myself some board space here. Let's suppose that I'm supposed to simplify the following. Let's suppose that I'm supposed to simplify the square root of 200. Well, my first order of business is to break 200 down into its prime factorization. So what I'm going to do is I'm just going to say, well, I know that 200 is just 20 times 10. And 10 is just 2 times 5. 20 could be broken down into 4 times 5. 4 could be broken down into 2 times 2. At this point, I've reached my prime numbers. I cannot go any further. So the square root of 200 is equal to the square root of 2 times 2 times 2 times 5 times 5. And then remember my expression that every pair underneath the radical equals one representative on the outside of the radical. So I see a pair of 2's right here. I see a pair of 5's right here. For each pair, one representative comes out. So this is going to be 2 times 5. This 2 is unpaired. It remains underneath the radical. My final answer is going to be 10 root 2. 10 root 2. Now, let me see if I could do 2 more problems. Let's suppose that I'm asked to find negative root 49a to the 4th power. Negative root 49 times a to the 4th power. Well, I am just going to keep this negative along every time I rewrite this expression. So I'm going to write negative, and then 49, I already know that that's just 7 times 7. Now, I could break down a to the 4th into 2 factors that are completely equivalent. I could break this down into a squared times a squared. When you write this, make sure that your radical symbol goes all the way to the end. Now, when I take a look at this, I'm able to see that I have 2 pairs, a pair of 7's here, and a pair of a squareds there. So what I'm going to have is negative from right here, 7a squared. 7 because one representative comes out from that group, and a squared because one representative comes out from that group. My answer here is negative 7a squared. Well, let me close this with one more problem, a problem that I think is kind of challenging, but I think that now we have all the tools in order to get to it. My third and final problem is to simplify the square root of 50 x to the 12th y to the 9th. 50 times x to the 12th times y to the 9th. Well, here's what I want to do first. Let me just deal with the number first. I'm going to, again, split that number into its prime factors. So 50 breaks down into 5 times 10. 5 cannot be broken down any further, but 10 is just 2 times 5. So this could be broken down into root 2 times 5 times 5. Now let's deal with this x to the 12th. As it turns out, x to the 12th can be broken down into two equivalent factors. X to the 6th times x to the 6th. But y to the 9th, because the exponent is an odd number, unfortunately, it doesn't break down nicely into two equivalent factors. So what I want to do is I'm going to rewrite y to the 9th. I'm going to rewrite it as y to the 8th times y. Because now that I have something to an even exponent, that does break down nicely. This is equivalent to y to the 4th times y to the 4th, and then this y just comes down from above. So I'm going to write these factors in here. I have y to the 4th times y to the 4th times y. Now you guys remember that every time I see a group of 2 underneath the square root, one representative comes out. Well, I see a group of 2 5s, so one representative comes out. I see a group of 2x to the 6s, one representative comes out. I see a group of 2 y to the 4ths, one representative comes out. Now everything that I haven't dealt with, and everything that's not paired, remains underneath the radical. This is going to be 2y. So my final answer will be 5x to the 6th, y to the 4th, times the square root of 2y. Well, thank you for joining me. This is Cliff from Redwood Tutoring. Have a great day.